Let's look at this problem before we start the converting of the unit for the air pollution. Let's see that what is the carbon monoxide. So carbon monoxide, he needs the concentration of that carbon monoxide in microgram per meter cube. Okay? He collected 10-liter gas mixture that contained 10 to the minus 6 mole. So he collected 10 liter of gas, and that 10 liter contained 10 to the minus 6 mole of CO. So how could we convert this into a unit? So you can see 10 to the minus 6 mole CO over 10 liter. So you can see that mole carbon monoxide per liter, this is the unit, which is molarity. So 10 to the minus 6 over 10, that's 10 to the minus what? 10 to the minus 7, molarity. Now, how could you change mole per liter into gram? So let's look at this. 10 to the minus 7 mole CO over liter, which is the liter, the containing mixture of air. You multiply it by the molecular weight of carbon monoxide. The molecular weight of carbon monoxide is 28 gram per mole, and you could find the carbon and the oxygen from the periodic table. Carbon is 12. Oxygen is 16, and that is 28 gram per mole. Okay? So, we want to get rid of the mole, so we multiply it by 28, the molecular weight of carbon monoxide, 28 gram per mole, of course, mole CO. So this is cancelled with this. Now you'll end up with gram per liter. You multiply 10 to the minus 7 times 28. Okay, and now for the he wants the unit in microgram per meter cube, so you convert gram into microgram, and 1 gram is equal 10 to the 6. Now 10 to the 6 with this is 10 to the minus 1. 10 to the minus 1, which is like 0.1. 0.1 times 28 microgram per liter, but he wanted in meter cube at the bottom. So let's do it here. 0.1 times 2.8 is 28 is 2.8, and that is microgram per liter. Liter top, meter cube at the bottom, and we know that 1 meter cube is equal 1,000 liter, and this would make it 2800 microgram per meter cube. So this is the concentration. If we collect 10 liter mixture, this 10 liter mixture will contain 10 to the minus 6 mole of CO. The concentration of that carbon monoxide is 2,800 microgram per meter cube. Okay, so now we found the concentration. How are we going to do this? It's like a small device. Okay, and it is a vacuum. This device, it will suck air from the room, and let's say there is a maximum volume of that the air will be sucked inside this small tank, and the maximum that this powerful vacuum is 10 liter maximum. So it will suck 10 liter air. So we took this to the gas chromatography, and we checked how much carbon monoxide in this 10 liter. And the gas chromatography found out it's 10 to the minus 6 mole. So from this analysis of carbon monoxide, we could find the concentration. And once we find the concentration, we could use this equation, remember the equation that we just showed before, this equation to convert it from microgram per meter cube into part per million. This is only for air pollution. Okay, molecular weight of that compound 1000 is the conversion. P is always 1 atmospheric, R is constant, and T is constant. T is the temperature in Kelvin, sorry. Okay, so most of the time we're going to use this R, 0.08205 liter atmospheric over mole Kelvin. Of course, R is different with different units. Okay, so depending on what is the unit that you are using inside this equation, you're gonna use this R. So in this class, we're gonna use this R a lot because this is the consistent with if we are using ppm, gram per mole, atmospheric, and R would be for temperature Kelvin and everything else in the same units that we're gonna be using in this class. This question also was given in the notes, and I think it is clean air might have a sulfur dioxide SO2 concentration, so the sulfur dioxide is 0.02 ppm. The polluted air might have a concentration of 2 ppm. Convert this to concentration to microgram per meter cube. So he wants to convert 0.01 ppm and 2 ppm to microgram per meter cube. So remember that we were using the same equation in the notes in the class. So you want to make it microgram per meter cube. So ppm, the first one. The first one was what? It's 0.01. So 0.01 is 1 10 to the minus 2. Molecular weight of SO2 from the periodic table. S, silver, oxygen. And there's 2 oxygens. Okay, 64.1, 1000. And of course, we had to multiply it by 1 atmospheric because pressure is 1 over 0.08205 R and the temperature in Kelvin. Okay, so you add the temperature in Celsius plus 273. Okay, and that is in Kelvin. So you could find out that the 0.01 ppm is equivalent to 26 microgram per meter cube. Same thing for the other one. The 2 ppm is equivalent to 5,243 microgram per meter cube. This question, which makes sense for you to compare between a standard and whatever you are analyzing. And this is similar to this going to be coming in the quiz. Carbon monoxide affects the oxygen carrying capacity of your lungs. Exposure to 50 ppm carbon monoxide for 90 minutes has been found to impair one's ability to time interval discriminate. Thus, motorists in heavily polluted areas may be more prone to accident. So this is standard. 50 ppm for 90 minutes. So if anyone were exposed for more than 50 ppm for 90 minutes, it's a violation. They could lose the ability to concentrate, and then they will have accident. So are motorists at a greater risk to accident if the CO concentration was 65 milligram per meter cube? It's not microgram. Remember the equation? Microgram. This is milligram. Assumed temperature is 298 Kelvin. So now we have to convert this to ppm. So you could compare it with the standard. This is the standard. Okay? So let's use the same equation. First of all, 60 milligram, remember the milligram, 60 milligram per meter cube. Remember the equation? It used, I'll just try to look for the equation again. The equation used microgram per meter cube, not milligram. So we have to convert this to microgram per meter cube. So milligram to microgram. 1 milligram is equal to 1,000 micrograms. So milligram with milligram, and you'll end up with 60,000. 65, sorry. So this is 65. So 65,000. Is this 65? Yeah, 65,000. So 65,000 microgram per meter cube, and that is the conversion from milligram to microgram. And then you're going to put it into the equation. ppm is unknown. The molecular weight of carbon monoxide, you remember 12 and 16, 28. So 28 gram per mole, this is unknown. And then 1000, this is always conversion factor times 1, the pressure, atmospheric, over 0.08205, this is R, over temperature. He assumed the temperature as 298 Kelvin. So now the value is 57. So it is 57 ppm. What is the standard? This is what people are being exposed in the street. 57, and now the standard is 50 ppm. So the carbon monoxide concentration in air is 57 ppm. That is higher than the standard, which means that, yes, these motorists or those motorists are at greater risk of having car accidents. Same thing here, if you want to look at this question, that the ice resurfacing machines are used internal, the exhaust system will produce carbon monoxide all over the ice skating, so high carbon monoxide and high nitrogen oxide, or NOx. The average CO concentration measured in the local ice rink have been reported 107 when the machines are on, and 36 when there is no machines, and it's really the ventilation system are trying their best to take all this pollutant out. But let's look at the standard. How do these concentrations compare to an outdoor air quality? Outdoor air quality 1 hour, standard of 35 milligram per meter cube. Okay, so this is the highest and that's the lowest inside the ice skating rink. And this is the standard for 1 hour. Okay, 35 milligram per meter cube. Now, we want to convert either, the best is to make, because here there's two values, and this is one value standard, so you could convert the standard if you want to. So 35 milligram meter cube, you could convert the milligram to microgram, and this is going to be 35,000 microgram per meter cube, and this is the standard. Of course, we need to find the ppm. 28 is the molecular weight, 1,000, 1 atmospheric over R over temperature. And then you're going to get that it is 30 ppm, and this is the standard. You can see that both values, the highest and the lowest, is much bigger than the standard. So there is a violation whether the machine is on or the ventilation system is really trying its best to clean up the air inside the ice skating rink. So there is a violation. There is a violation. The carbon monoxide inside this ice rink is violating the air pollution regulation. This one we did mention this in class, but this is also one of the questions that you don't have to just do it using what the book is doing. So here, the concentration of SO2 is measured in air to be 100 part per billion. What is this concentration in the unit of microgram per meter cube? So you want to convert this to microgram per meter cube. Of course, temperature is 28, and you have to add this to 28. And of course, pressure is 1 atmospheric, and temperature should be in Kelvin. So remember, it is in ppm, not ppp. So part per billion and part per million are different. So we have to convert this into part per billion divided by 1,000. It is 0.1 part per million. Okay, part per million. So from this, you could just use the equation and then plug it into this equation here. Okay, so you have the 0.1, you have the molecular weight, you have the 1,000 P, R, and T, and you could find the microgram per meter cube, which will give you, and this is good for you to practice, and hopefully you will find this answer. Okay, thank you very much.